Let's take a look at unit vectors. Let's talk about this notation. We're going to let the letter U represent our unit vector. And to find that, we're going to take vector v on top and divide it by the magnitude of v. This is probably the most common way you're going to see this formula written. You might also see it written this way. All they did here was multiply both sides here by the magnitude of v. So the other way you might see it is v equals our unit vector times the magnitude of v. Let's take a look at an example. In this problem, we want to find the unit vector in the same direction as vector v. And vector v is equivalent to 4i minus 3j, or vector 4, negative 3. Remember that when you're finding a unit vectors have a length of 1 unit. We want this vector to be in the same direction as vector v. We're going to start this problem by finding the magnitude of v. To calculate that, we're going to take 4 squared plus negative 3 squared, which will give us 16 plus 9, and then we want to take the square root of that. So we're going to get the square root of 25, or in this case, a magnitude of 5. Let's go take a look at our unit vector formula. I'm going to go ahead and make one small edit to this formula just to make things a little bit more clear as we move forward. Keep in mind when you're working with this fraction, this is the same thing as saying vector v times 1 over the magnitude of v. The magnitude of v was 5, so we have 1/5 times vector v, which is the vector 4, negative 3. Let's go ahead and distribute this 1/5 to each component. When we do that, we're going to get the vector 4/5, comma, negative 3/5. This is our unit vector, which means it has a length of 1. Let's go ahead and take a look at that proof, just so we can verify that it really does have a length of 1. So we're going to go ahead and calculate the magnitude of u, and we're expecting that to come out to be a 1 once we're done. We're going to square each of these components. Remember what it means when you square a fraction. You're going to be squaring the top and the bottom part of the fraction. When we square them, we're going to get 16 25ths plus 9 25ths. And if we add those together, that's going to give us a 25 on top and 25 on the bottom. We can divide these out to get a positive 1, and then we have to go ahead and take the square root. So our final answer for this unit vector, obviously it has a length of 1. So if we plot our unit vector and our original vector on the same graph, they would be going in the exact same direction. The only difference is this unit vector obviously is only going to have a length of 1.